Okay, the Unit 5 test review. This is over distance and midpoint, slopes of lines, and then equations of lines. The midpoint, we have the formula here, which is really just the average of our x's and the average of your y's. So when I combine these, I have negative 3 plus 5 over 2. Negative 3 and 5 is 2 over 2, results in 1. And I have 7 plus 5 over 2, which is 12 over 2, and 6. In the second one here, dealing with midpoint, I have a segment, A to C, has midpoint M. And I know that by virtue of it being a midpoint, it creates two congruent segments, A to M and M to C, which I know are 6x plus 7 and 4x plus 5. That allows me to then set them equal, create my equation so that I can solve. Little rearranging, minus 4x's, minus 7 from both sides, and I have 2x equals negative 2. Divide by 2, and x equals negative 1. Now I need to find the distance from A to C, so I substitute. 6 times negative 1 is negative 6, plus 7 is 1. Doubled would be a distance of 2. Number 3 here. Now I know the midpoint. It's at 1, 4. I have a segment FG where I know point F. It's 5, 1, but I don't know G. So we'll use XY. So I do this in the same manner, but I set it up a little differently. Now I know the midpoint, so instead of M being an unknown value, I know it's 1, 4. And that will be equal to the average of your x's, which is 5 plus my unknown x over 2, and then 1 plus my unknown y over 2. So I create these two separate equations, knowing that 5 plus x over 2 will equal the x component of my midpoint. First step is to multiply both sides by 2. So now I just have these cancel. 5 plus x equals 2. Subtract 5 from both sides. And I know that the x value is negative 3. Okay, I do the same thing here for the y's. I'm going to set up my equation. 1 plus y over 2 equals 4, the y component of the midpoint. I multiply both sides by 2 to clear the 2 out of the denominator. And I'm left with 1 plus y equals 8. Subtract 1 from both sides, and y is 7. In 4, to find the length of A to B, simplest way when you're given a graph is to just create a right triangle out of it and to use the Pythagorean theorem. By counting, I know that the distance from A to this vertex is 8, and from here to B is also 8. So I set it up in Pythagorean theorem. 8 squared plus 8 squared equals my hypotenuse squared. This then becomes, a little rearranging, C equals the square root of 128. Crunch that in your calculator and you'll get approximately 11.3. In number 5, we have a similar problem, but we're talking now specifically about a high school football team. And we have a point 5.4. And then 1, 2. So this time, I'm going to find the midpoint first. So I just add my x's. It's 6 over 2, which is 3. Add your y's. 2 plus 4 over 2, which is 6 over 2 is 3. There's your midpoint. This time I'll use the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. And then we substitute in our values. Doesn't matter which one you label the x1, y1s. So I'll just say 1 minus 5 squared plus 2 minus 4 squared. So this becomes 4 squared plus negative 2 squared. And we're going to take the square root of that. So this is 16 and 4. So this is the square root of 20. Put it in your calculator and you'll get approximately 4.47. Now, one thing to be cautious of is that is in units on the coordinate system, and it says each unit is 5.3. So I then need to multiply that by 5.3 to find my final answer, which will work out to approximately 23.7 miles. Now, we've seen this type of problem before. We're looking for the distance saved. So I see that to walk from P to Q is 4 units, and 7 from Q to R, so the total distance there is 11. If I use Pythagorean theorem to find my hypotenuse, I'll see that that would be the square root of 65, which works out to approximately 8.06. So subtract that from the original distance, walking from P to Q, then Q to R, and I'm left with the distance saved of 2.94 feet. Finding the slope on a graph should be pretty straightforward. All we do is count. I went down 3 over 4, rise over run. We always run to the right, so down means it is negative. This one's a little bit harder just because of the size. I went down 1 over 2, rise over run is negative 1/2. Slope. Your slope formula here is given. Change in y over change in x. You can label if you want to. Doesn't really matter which one you call the 1s and the 2s. So if I put the y's on top, negative 4 minus negative 3 over negative 1 minus negative 5. Negative 4 minus a negative is going to be a positive, so I'm left with negative 1. Negative 1 minus a negative is a positive, so I'm left with 4, and there is my slope, negative 1/4. I do the same thing here. 6 minus 2 over negative 3 minus negative 4. 4 on top, negative 3, this becomes a plus 4. So I have a slope here of 4 over 1, which is simply 4. Line parallel to this line, well, I know that parallel has the same slope. That's why they will never intersect. In order to determine the slope, I'm going to need to solve this for y. So my first step is to subtract 4 x's from both sides. And then I divide both sides by negative 3. I'm left with y equals negative over negative is positive. So I have 4/3 x, and then I have a positive over negative, which will be minus 4. But what I'm concerned about is the slope, and I see that it is 4/3. Okay, on to the next page. Slope of a line perpendicular to this one. Well, it's already in SlopeIntercept, so I see my m, the slope's right there. And I know that perpendicular means that they intercept at a right angle. And those are the opposite reciprocals. Or the products will equal negative 1. Or flipped and whipped. So if I flip the sign of a positive, it becomes a negative. 3 written as a fraction is 3 over 1. So when I whip this around, it becomes 1/3. When I take the product of 1/3 and 3, it will always produce a negative 1. So I can be sure that they are perpendicular. Describe the relationship. So we're going to look at their slopes. So I can label. I put my y's on top. Negative 2 minus a negative becomes a positive, leaves me with a negative 1, becomes a positive, so I have negative 1/3. And I have negative 4 minus negative 3 over negative 1 minus negative 5. Remember, this is a positive, so I have negative 1 on top again, positive, so this time I'm left with 4. So I have negative 1/3 and negative 1/4. How do those compare? Well, they are neither parallel nor perpendicular, so we refer to them as oblique. A line passing through this point, again, we're going to look at its slope. So we'll label 5 minus 5 on top, 3 minus 1 on the bottom is 0 over 2. 0 divided by anything will always be 0. That means it has no steepness, no slope, which is a flat line, a horizontal line which has a slope of 0. Correct answer there being C. Linear relationship represented by the rate of change of 3 over 4. I believe this should be 5 over 4. And then when you work this out, if the x here is gone, y equals mx plus b, what I really have here is the b, the intercept. So the value of m that makes the x disappear would have had to have been 0. So this actually is a horizontal line at 5/4 on y. So it has a 0 slope. When you rearrange this one, subtract 4x's from both sides. 5y equals negative 4x plus 10. Not concerned about the b, really just the slope here. This one has a slope then of negative 4/5. And on a table, you just look at your rate of change. Negative 5 to a 0 is plus 5, plus 5, plus 5. From negative 4 to 4 is a plus 4, plus 4, plus 4. Change in y over x, this does have a rate of change of 5/4. So it would be A. Which equation has a graph that's parallel? So it has the same slope, which I see right there. So all I'm really looking for is the same. That would be choice A. Perpendicular, remember this means intercept is at 90 degrees, so it is the opposite reciprocal. I see my slope here. 8 written as a fraction is 8 over 1. When I flip the sign, I know I'm looking for a negative. And when I whip it around, it becomes 1 over 8. So that again is answer A. 18, I need slope-intercept form of the equation. Two things you need to write it. You need the slope and the y-intercept. I know my slope. It's 5/2. What I'm looking for is b. So I want it to look like y equals mx plus b. Here I have an x and a y because it passes through this point. So I'm going to use that to substitute. So I have 0 equals my slope times the x plus b. So now I just have one unknown value, b. And I can solve. 5/2 times negative 4 is negative 20 over 2, so that's a negative 10. So 0 equals negative 10 plus b. I add 10 to both sides, and I see that b is 10. I can now write my equation. Y equals 5/2 x plus 10. I do the same thing down here, number 19. Parallel, so I know it has the same slope. Two things I need, the slope and the intercept. I know the slope because it's the same. I know it passes through this point, so I have an x and a y. So I use my equation, just a formula, and I substitute my known value, solve for the unknown. So 4 equals negative 5 times 7 plus my unknown quantity b. I add 35 to both sides, and I'm left with b equals 39. So negative 5x plus 39. And we work on down here to number 20. Slope-intercept form passing through here. There again is an x and a y. This time it is perpendicular. So here's my slope. So I know it's the opposite reciprocal. Change the sign. It becomes positive. 5/3 flipped becomes 3/5. So I'm looking for the b. So I have my okay, so I write out my equation, y equals mx plus b, and I substitute my known values. And I solve for the unknown b. 3/5 times 3 is 9 over 5. And then I subtract it from both sides. I'm left with b equals 2 1/5. And sorry, it's not 2 1/5. It's 21/5, which would be 4 1/5. So, however you choose to write it is fine. Y equals 3/5 x plus 21 over 5. Okay, last couple here. Equation line given a graph in slope-intercept form. Well, I should be able to find my slope simply by counting 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4. If I went down 6, 4 over, rise over run, this reduces to 3/2. So my slope is negative 3 over 2. Now I need to find my intercept. I see that it does not cross exactly at a whole value. So what I can do is pick a point. I'm going to take 1, negative 2, and I make it my x and y. I do the same thing I was doing up above, and I substitute my values. So the y value I've chosen, negative 2 equals my slope times the x plus b. So this is just negative 3/2. I add it to both sides. So 2 times 1.5 becomes 3.5. Oh, I'm sorry, it's negative 2, and I'm adding 1.5 to it. So I'm left with b equals negative 1/2. And I write my new equation. Y equals negative 3/2 x minus 1/2. And I can see that appears to be right where it's at. Crosses at negative 1/2 on the y. Okay, last two. Slope-intercept form passing through this point parallel to this. Well, parallel, I know it has the same slope, so there's one part of it. Now I just need to find the b. I have an x and a y, so I write my equation, and I substitute my values. Times the x, and my only unknown here again is b. Negative 1/4 times 4 is negative 4 over 4, or negative 1. So 8 equals negative 1 plus b. I add 1 to both sides, and I get b equals 9. So my equation, y equals 1/4 x plus 9. And the final problem. Passes through the point negative 2, negative 7, and is perpendicular. So if this is my slope, minus the opposite reciprocal, it becomes negative. Whip it around, 1/2. So I need to find b. So I start with my equation, y equals mx plus b, substitute the known values, and solve for the unknown b. So I have negative 7, negative 1/2 times negative 2 is a positive 2 over 2, or a positive 1. And subtract 1 from both sides, and b equals negative 8. Your equation then, y equals negative 1/2 x minus 8.